Hello and welcome to Solar Powered 3D Printing. My name is Brian and today I'll share an accelerated video of my workflow as I design a simple ground mount solar array using conventional hardware that we should be able to find from all the big home improvement stores such as Lowe's and Home Depot. The video is not intended to be a tutorial but may give you some inspiration for your own design. I do plan to build this array and share it with you in an upcoming video. Modeling something like this usually helps me discover flaws in a design and tally up an accurate materials list. I'm going to start by modeling the 4x4 posts. Of course, the posts have a real world dimension of 3.5 by 3.5 inches, so I'll appropriately account for that. I'm going to use a total of 6 posts to support each array with an overall footprint of 8 foot by 19.45 foot centered. So essentially, 8 foot centered from front to back and 9.725 feet centered from side to side, or side to center post. This will support the frame, which will be a 10 foot by roughly 20 foot on a 30-degree inclination. Here you can see I'm adding in a 2x6 cut at a 10 foot length and I'm placing it on the structure at a 30-degree slope. This will face due south. I do plan to use 10 foot lengths throughout the structure for simplicity. Here you can see I'm putting in a midpoint beam. I'm going to put that at 4.86 feet off of center post. I'll be making the connection between the 2x6s using joist hangers. These will be held in place with deck screws. The area where I'll be building these is naturally sloped in the same direction as the array itself, though not as steep, so my goal will be to get these things as low to the ground as practical. I think the high side will be about 6 feet off the ground, with the low side being approximately 1 foot off the ground. I'm going to use 10 foot by 1 5/8 12 gauge unistruts to make the connections directly to the 2x6s. I'll be using 5/16 lag bolts with washers to make the connection to the 2x6s at every intersection. The offset distance between the unistruts from top to bottom will match the existing hole offsets found on the underside of the frames of my solar panels. The panel dimensions are going to be 64.5 by 38.7 by 1.57 inches. I'd like to give these a spacing of 1 inch between the 6 panels on each side of the array, with a larger spacing down the center. I'm not really going to use any precise dimensions to space these, I'm just going to make them look right. I plan to make the connection between the unistrut and panel using 1/4" spring nuts, 1/4 by 1" bolts, 1/4" star washers, 1/4" standard washers, and 1/4" lock washers. I already have a lot of this stuff on hand, but otherwise I would probably have opted to go down the road of using standard solar panel clamps. I'm going to build 2 of these arrays, so by pulling a copy off and placing it in the approximate offset, it helps me to kind of visualize the whole project and how I might route the wire. I'm adding a little texture to the components, which doesn't necessarily help the model, but it does add a little contrast, which could help identify a problem that I previously missed. I decided to use 1/2" diameter carrier bolts here in lieu of lag bolts for the connections between the 4x4 post and the intersecting 2x6s. This will require 6" bolts on the outside corner posts and 8" bolts at the center posts. I know a lot of folks may think it's overkill to account for things like bolts in a DIY design like this, but if there's going to be a conflict between components, I'd rather find it sitting in the AC at a computer and not when I'm constructing the structure. I plan to add some cross bracing, but may wait on modeling it because its placement may be dictated in part by the location of the combiner box. The combiner box's location may be dictated by soil conditions because I want a straight shot from the ground to the box. So that may be a field modification. Anyway, thanks for watching. Make sure to subscribe if you haven't and stay tuned for next time here at Solar Powered 3D Printing.